And number 2 here, finding a horizontal asymptote. That's going to be covered in chapter 3.5 about rational functions. And so you look at just the leading term on the top and the bottom. And if the bottom leading term has a larger exponent, then the horizontal asymptote is y equals 0. If they have the same exponent like this, they both have a 2 here, then the horizontal asymptote is just the ratio of their coefficients, which in this term would be 8 over 8, or that reduces to 1. So in this case, the horizontal asymptote is at the line y equals to 1. In number 5 here, we have an arithmetic sequence where we start off with doing 12 push-ups on the first day, and we're adding 3 every single day. So if we were writing out this sequence here, we have 12, day 2 is going to be 15, day 3 you do 18 push-ups, and so on for the whole 30 days of the month. Now there's nice little formulas for adding up or summing the first so many terms of a sequence. And these is in 7.2 over arithmetic sequences and series, but summing up the first 30 terms, so S sub 30, and when it's written out, it just has an n here, S sub n, but I'm plugging in 30 for n because I know there are 30 days in this month. So then you do 2 times a1, which is the very first term, which is 12, so 2 times 12, which is going to give us 24, and then plus n minus 1, so our total 30 minus 1, which is 29, and that's multiplied by the d, the difference between each successive term. So our difference here is 3, because we're increasing by 3 push-ups every single day. So here we get 15, and then 24, and what would that be? 87? Yeah, it's 87. And then so our sum of the 30 days of this is going to be 15 times 111. Those two terms add up to 111. So I would bust out my calculator here. 15 times 111. And you get 1665 is how many push-ups you would do over the course of that 30-day month. For this question, we're looking to see if the graph is symmetric with respect to the y-axis, the x-axis, the origin, or none of these. And so here is the equation, and this is covered in 2.7 on graphing techniques. So to check to see if it is symmetric about the y-axis, you plug in a negative x for x. Just swap out every x with a negative x and see if you get the same exact result. So if you had a negative x to the 5th power, and then you put a negative x here to the 3rd power. So if this gives us back the same exact result as the original equation, then we have symmetry around the y-axis. Well, it's going to be different because when you raise something to the 5th power and it's negative, it gives you back a negative. So you'd actually have minus 6x to the 5th. And then this term would be negative as well, minus 3x to the 3rd, because we're getting a negative introduced here. And so we get a different equation than when we had positive x's here. So it's not symmetric with the y-axis. Now with the x-axis, you plug a negative y in everywhere there was a y, and see if you get something equivalent back. So that would be, you have a negative y, and everything over here stays the same. Now, if this was the same as the first equation, it's symmetric with respect to the x-axis. And this is a different equation. It's got a negative on the left side, so it's not the same. So we do not have symmetry with respect to the x-axis. Now, symmetry with respect to the origin is you replace both the x's and the y's with negative. So you would have a negative over there, negative x to the 5th, plus 3, negative x to the 3rd. Does this give us the same exact equation back? Well, it is actually going to in the end, because this term gets a negative introduced, this term, just like we saw up here, also gets a negative introduced because a negative variable number to a odd exponent is still negative. So we have this, which both sides now are just the negative of what they were to start with, which means if we multiplied everything here by -1, we have the same exact equation that we started with. So this is equivalent to what we started with, so we do have symmetry around the origin. And here I've graphed this, so you can kind of look at the graph too and tell a lot of times. So if it was symmetric across the x-axis, you could reflect it across the x-axis and get the same picture, which we wouldn't get here because if you reflect across this line, this piece would be down here, which there is no piece there in the original graph. And this piece would be up here, which there is no piece in the original graph. And reflecting across the y-axis, this piece would be over here. And there's no piece like that in the original graph. And this piece would be over here if you just reflect it across this line. Now, symmetry about the origin is like doing a 180-degree twist. And if you turn this thing 180 degrees, this piece would line up exactly with that piece. And this piece turned 180 degrees would line up exactly with that piece. So visually, we see the symmetry as well. For number 26, we have two functions. Their graphs are shown here. This is f of x, and this one's g of x. And we're going to use these graphs to find f of -4 minus g of -4. So let me get a little clear space here. F of -4 means look at the f graph here, go to where x is -4, 1, 2, 3, 4, and see what the function value is. What is f of that? And it's right here. This is where the function is when x is -4, and so it is -1. And g of -4, we look at the g graph, and again we go to where g is negative, or where x is -4, and look at what the g function is when x is -4, and it's up here at a +4. And so it says we want to subtract f of -4 minus g of -4. So we're doing -1 minus 4, and that gives us our result of -5. So for 28, it's asking us what is f of 4 going to be for this function. So this is a function that looks completely different depending on what x is. If we're looking at x is less than 0, it's this line. When x is in between 0 and 3, it's this line. And then when x is anything 3 or greater, it is just x, which is another line. So depending on what your x value is, the function itself looks completely different. It's called a piecewise function. So f of 4, well, we look over here at the parameters. For x4, we would be on this part right here, because 4 is greater than or equal to 3. So we're plugging in the value 4 into this function here and seeing what the result is. And it's just x, so when you plug a 4 in, the result's 4. Our answer here would be 4. If it said something like, what is f of 2, then we would plug the value 2 into this function, because 2 is in between 0 and 3. And our result would be 2 minus 6, because you plug a 2 in, you get 6. So our answer would be -4. And if we had any negative value, let's say -1, we would be using this function, because that's less than 0. So f of -1, you would plug a -1 in here and get your result. For 29 here, we essentially have a linear function, and they give us 2 points on the line. So if we make 11 airplanes, it costs this much money. That's the point where our x is 11, our y is 140,000. Our x is the number of planes made, and our y is how much it costs. And then when x is 29, our y is, as it says here, 150,800. And y is the cost, like I stated, and x is the number of airplanes. So anytime you have 2 points and you're trying to create a linear function, you need to just find the slope first. So rise over run. You put and I think I have one too many zeros there. You put the y values on top, subtract the y values, And on bottom, making sure you list the points in the same order, you subtract the x values. And that's going to give us the slope here. So the difference between these two is 10,800. And the difference there is 18. And let's see if that reduces nicely. 10,800 divided by 18. We have a slope of 600. Now what that slope of 600 means is that for every additional plane we make, it costs 600 extra dollars. So y equals 600x plus b. Y equals mx plus b. We solve for the slope 600. Now to completely get the equation of the line, we need to know what b is. We can plug in either one of our original points. And I'll just use this first one since the numbers are a little smaller. But if you have y equals 600 times 11 plus b, I shouldn't have entered y. When x is 11, what does y equal? It equals 140,000. So you just plug in one of the points, the y value for y, the x value for x, and you solve this here. 600 times 11 equals 6,600. And so when we subtract, we're going to take our 140,000 and subtract 6,600. And we get 133,400 is our b. So our final equation is y equals 600x plus 133,400. That is the equation of the line. And when you plug an 11 in, you get back this value. When you plug in a 29, you get back that value. For number 30, a town has a population of 10,000 and it's increasing by 10% every year. And then the question is, what will the population be at the end of 5 years? So here's the equation of how you get the increase for 1 year at 10%. You have your original population of 10,000 and it goes up by 10%. So you're multiplying it by 1.10 to show that 10% increase. Now that would give you your new value after 1 year, and you would take that and you would multiply it again by 1.10% because there's another 10% increase. That's your value after 2 years. After 3 years, you again multiply it by 1.10 to show it going up by 10 more percent. Now, and so on and so forth, we can see we're multiplying by the same number over and over. So that can be written shorthand where you multiply it by an exponent. So however many years you want to calculate it, you would plug that into the exponent here and get the size of the town after that many years. So after 5 years, you're just plugging a 5 up there in the exponent and then calculating 1.10 to the 5th and multiply that by 10,000. So doing that here in Excel, this would be the population of the town after 5 years. We can't have a decimal of a person, so we would round that to the closest number down, 16,105. For number 31, find the equation of a circle with a given center and a point that it passes through. And we want to show that equation in center radius form. Now this is covered back in chapter 2.2 over circles. And so this quick sketch here, negative 4, 4, and this is the point 212. And so the circle, this is a really rough drawing, but there's the center, and it goes through this point. So this is the equation here in center radius form. You do x minus the x value of the center, which is negative 4. So minus the negative 4 would be plus 4 squared. And then you do y minus the y value in the center of the circle, which is 4. So y minus 4 squared. And that equals the radius squared. Now, to find the radius, we're going to need to use the distance formula between the 2 points we know, the point on the outside of the circle and then the center. And so the distance formula, you subtract the y values and square them, subtract the x values and square them. So 12 minus 4 is 8, 8 squared 64. 2 minus a negative 4 is 6. 6 squared is 36. Add those together, you get 100. Square root of 100 equals 10. So our radius, the length of this segment here, is 10. Well, we want our radius squared to be on the right side, so that would be then our final equation in center radius form.